Good evening, student. Today we will start our next topic, relationship between nearest neighbor distance d and radius of atom r and S of the unit cell A in the cubic system. As we know that cubic system is one of the most symmetrical crystal system in which all three edges are equal and all three interfacial angle is also equal to 90 degree. Then we can write for cubic system is A equal to B equal to C and interfacial angle alpha equal to beta equal to gamma equal to 90 degree. Now we start our first type of unit cell, that is simple cubic unit cell. As we know that in case of simple cubic unit cell, constituent particles are present only at its corner. Then in case of simple cubic unit cell, constituent particle, that is atom, ion or molecules, are present only at corners. If we draw a simple cubic unit cell, then we find its all three edges are identical and interfacial angle is also equal to 90 degree, and constituent particles, that is atoms, are present only at its corner. Now we discuss here about the relationship between D, A and R. Then we can say that the atom at corners touch each other along the edges. Let's suppose this is our atom A and this is atom B. They both touch each other along the edge A. For your convenience, we draw this structure separately. This is half of distance, means radius r for this atom, atom A, and this is atom B. This is r for radius for atom B. Now the distance between, this is the distance D. Now neighbor distance D equal to A and B, which is also equal to edge length A, and this is also equal to radius r, and radius r means 2r. Now we can write r equal to A by 2 or r equals to 0.5 A, where r equal to atomic radius. our next type of cubic unit cell is face-centered cubic unit cell, FCC. As we know that in case of face-centered cubic unit cell, constituent particles are present at all corners as well as center of each faces. Now we draw a structure of face-centered cubic unit cell in which constituent particles are present at all corners as well as center of each face. Phase 1, phase 2, phase 3, 4, 5 and 6. Here we talk about neighbor distance between atoms. So neighbor distance, this is the neighbor distance between them, and this is again neighbor distance between them. Now we suppose this is atom A, this is atom B, and this is atom C. Now we find a triangle ABC. By applying Pythagoras theorem, we find that AC equal to AB square plus BC square, where AB, the edge length of A and B is A square, and edge length of B and C is also A square. Then AB square is edge length A square, and for BC square edge length B square. Then AC square equal to 2A square. For AC, under root 2 into A. If we find the relation of distance D, then distance D is equal to AC by 2. So D equals to AC by 2. Then AC equals to under root 2 into A upon 2. This is further multiplied by under root 2 into under root 2. This root 2 cancel this root 2, and finally we got A by root 2. This is the relationship of D. D equals to A by root 2. Now for radius, atomic radius R. Atomic radius R equals to D by 2. D by 2. Then we can write D up is A upon 2 root 2. This is the relation of R for face-centered cubic unit cell. Now we discuss our third type of cubic unit cell, that is body-centered cubic unit cell, BCC. In case of body-centered cubic unit cell, the constituent particles are present at all 8 corners as well as center of unit cell. Now we draw a body-centered cubic unit cell in which the constituent particles are present at all 8 corners as well as center of the body of unit cell. Now we discuss here the neighbor distance between atom. Then two neighbor distance between atom is, first neighbor distance is this, and second neighbor distance is this. Let's suppose this is our atom A, this is atom B, this is atom C, this is atom D, and this is our atom E. Now here we find two triangles. Our first triangle is, in first triangle, A, B and C, A, B, C, by applying Pythagoras theorem, AC square equal to AB square plus BC square. For AB square, A's length is A square. For BC square, A's length is also A square. Then for AC square, A's length is 2A square. In triangle ADC, by applying Pythagoras theorem, AD square equal to CD square plus AC square. And now for CD square, A's length is A square, and for AC square, A's length is 2A square. Now AD square equal to 3A square, and for AD root 3 into A. Now for relationship of D, we know that AD by 2, then the value of AD is root 3 into A, root 3 into A by 2. Here D equals to under root 3 into A by 2. Now we find the atomic radius R equal to D by 2. Here D is under root 3 into A by 2 by 2. Then we can write under root 3 into A, root 2 into root 2, root 4. Then R equals to under root 3 into A by 4. This is our expression for R for body centered cubic unit cell. Thank you.